linear programming problem, and we are going to be maximizing x1 plus 2x2 minus 4 equals z with the constraints x1, 2x2,
3x3 is less than or equal to 24. 3x2 plus 7x3 plus x4 is less than or equal to 42. And then x1, x2, x3, and x4 are all greater than 0.
And these are constraints. And first we have to look here and see if it's in perfect canonical form, or PCF. And it is not. For example, here there's a x3 in these two, there's a x2 in all of them, x1 in all of them, and an x4 in those. So we have to add variables to it in order to make it into a perfect canonical form. And so you'd add s1, and then you'd add s2 to the equation. And so once you do that, you then have to make sure the equation is maximized, but that way when you maximize an equation, you have to make sure when you maximize a problem, you have to minimize the constraints and equations, and they are all minimized. And so you will then take them here and then move the z over here in order for that to work. And then after you do this, you would just after you do this, you would enter in the added variables here. S1 and S2 are the ones that I chose, and then you'd fill it in for the equation. So, and you also put it here. There it is. Okay. And so once you do that, you'll then fill out the squares to match this equation. And I start from the bottom just because z is there. And so z, there's 1z. There's
x1, -2, this is 0, x1, 0, and 0, and this is equal to 0. And then I'll go back to top. x1, sorry, z0, x1, 2x, 3x3, and then there's no whether. And then this would be 24. Oh, and you have to make sure less than or equal. The signs are that way, and they are, so it's good. So there's a 0 here, 0, 3, 7, 1 here, 1 there. And now you have a
full tableau. This is the initial. And so in this one, there are 2 negatives. So you have to make sure there's no negatives in the bottom half. So then you take the one with the smallest index, which would be x1, and you choose this one to start with. And in order to find which one it'll be, there's only a number here. So then you'll take this one and you'll put x1 and replace it with s1. So then it would be x1 and s2 at the bottom. And so, how long is it? Okay. In order for that to, so then you would use this row and make the other rows 0, and this one's already 0. So you would just leave that one alone since you don't do anything to it. Oh, you don't even put it on there. That's right. So you don't do anything to this one. You just fill these back out. And then for this last row, you're gonna add the first row onto it, and you're not gonna use any multipliers because you don't, to make it 0. So you'll make that 0. 0 plus 1 is 1. 2, can you see? Okay, 2 plus, okay, I'm stood over here. 2 plus -2 is 0. 3 plus 0 is 3. 0 plus 1 is 1. 1 plus 0 is 1. 0 plus 0 is 0. And 24 plus 0 is 24. And all of the numbers at the bottom here are positive, so you'll be done with changing the equations up. And so Oh, and this will be your Tableau too. And make sure when you're doing these that you write out your basic variables and your non-basic variables. For here, the basics would be S1, S2, and Z are equal to these things, and then the rest of the non-variables are equal to 0. And then the basic variables for this last one would be X1 and S2 are equal to 24 and 42, and Z is equal to 24. And then the non-basic variables are X2, X3, X4, and S1, and they're all equal to 0. And so with this, you would then take this and rewrite the equations. This equation, 3x3 plus x4 plus s1 is equal to 24, and then you have 3x2 plus 7x3 plus x4 plus s2 is equal to 42, and then x1, x2, 3x3 plus s1 is equal to 24. And so now you have equations that are in perfect canonical form. You have this one, this one,
that one.
This would be the optimum solution. Or I guess I can rewrite it. It would be like Z is equal to negative. My stomach's growling. This equation here and Z is equal to 24.